Hi everyone, Mr. Burke here, and this is going to be the third video on chapter 3. And in this video, we're going to kind of combine the work that we did between the first two videos, where we talked about the topics and what they were, as well as the calculations. And now we're going to be applying those to the homework questions, at least a selection of homework questions that I'm going to be doing. And we're actually gonna show those here, and then we're going to show how to be using StatCrunch, and then sometimes we may also be calculating things by hand. So we'll be going between the work in MyMathLab, the work in StatCrunch, and then sometimes my document at Canva as well, depending on what question we're answering here. So let's go ahead and let's take a look at the homework problem we're going to be looking at. Oops, where is that? Oh, right here. So find this here. I think this is it here. Okay, so for the first one here, I'm gonna take a look at. I'm not gonna look at all these questions, but the main that deal more directly with what we've discussed today, particularly the calculation here. So here's question. Here we go. So it says in this question, find the mean, median, mode, and mid-range of the data, and then answer the given questions that they're going to ask about here. So all right, so what we can do in a question like this when we're in MyMathLab is we should have, let's see, on this one, so it may look a little different on your side. I'm not sure how it's going to look for you, but if I want to get more help, I can go to here and I can select StatCrunch. And then what it's going to do is going to allow me to import the data directly into StatCrunch, so I don't have to worry about doing this. So I'm going to click on StatCrunch. This is going to go ahead and open up another window. So let me go ahead and do a new share for that window. I think this is going to be it right here. Yes, it is. And ooh, no, it didn't. Oh, guys, let me close that out actually. Let me show you how to do it. I didn't see this there before where I was looking. So let me close that. So if you want to bring this up in the StatCrunch, there's going to be this box here usually. I'm going to copy this into StatCrunch. So I'm going to open it directly into StatCrunch. And it's going to open up in StatCrunch with the data already in, which is actually quite nice. Yes, I know the data. Oh, yeah. So it's kind of reverting back here. Oh, okay. So let me kind of go back. Go to this problem originally. Okay. So I think, oops, there we go. I think I got this now. So yeah, guys, we're going through multiple screens. It's sometimes easy to fall off track here a little bit. So again, I'll try this. In order to bring this in the StatCrunch to use this, I'm gonna find this little box next to the data, and it's gonna say open in StatCrunch. And now this is going to open in StatCrunch with the data already preloaded. So I'm gonna do a new share for that. Okay, that should go right. This is what I'm looking for. Okay, so remember, if we want to, we're asked for this question to find the mean, median, mode, mid-range of the data, and then we're going to be answering some questions about this. So in order to do this, we're going to go to stat, summary stats for this column. Now you'll see the column is named var 1. So stat, summary stats column, go to var 1. You notice that it's going to have the mean, it's going to have down below it has the median. We can select the mode to make sure to hold down the control key and select the mode also so that it'll move over. It does not have mid-range. So you want to make sure that that this over here has the min and max, which it does because we'll show how the mid-range is calculated then. Okay, so let's go ahead and click compute. And then we can use this information here. So I'm going to record all the data at once. So well, you could stop and pause this here if you want to, but I'm going to go ahead and use this and I'm going to answer the questions on the previous page. Now, if I want to find the mid-range, it's going to be the min plus the max. So it's going to be 150 plus 275 divided by 2. So 150 plus 275, that's going to be 425 divided by 2. And 425 divided by 2 is going to be 212.5. So let's see. First off, it says the mean. So let's go back to the page where we're putting this information that we got on this page here. Now, be careful about rounding when you're doing this. It says type an integer or a decimal rounded to 1 decimal place as needed. So I'm gonna put in 176.5 here. Get my answer. Likes it so far. It says find the median. So it says here the median is 165. Remember, that's the number in the middle. Once the data is order from least to greatest, which makes sense because we have this up here. We have 2. Now normally we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We would take the 2 numbers in the middle and then take the average, but they're both 165, so that makes sense. That's going to be 165. It wants the mode. It says that the mode here is 150. Yep. Oh, guys, these are written order from greatest to least, which is unusual, but that's okay. And 150 is written 4 times, so that makes sense. 150 looks like the correct. Oops, not 150. And then the mid-range. We talked about the mid-range being the sum of the maximum and the minimum divided by 2, which was going to be 212.5. Okay. And let's talk about what this question was saying. It says, listed below the highest amount of net worths in millions of dollars of all celebrities. So these would be like basically your top 10 celebrities in terms of their net worth. Okay. What do the results tell us about the population of all celebrities? So what they're saying is we're given this sample of celebrities. Is this something we can generalize to the population of celebrities? Well, they're clear that the celebrities they selected weren't like just some random sample. They selected the top 10. So because of that, it says apart from the fact that all other celebrities have amounts of net worth lower than those given, the results part A, B, and D do not give meaningful results. However, the results from part C show that most common celebrities' net worth is equal to the mode. So I would say that's probably going to be hold on. Let me read this other one here. Apart from the fact that all celebrities have net worths lower than these, nothing meaningful can be known about population. Yeah, because we don't know if the mode is going to be the most common one for celebrities. Most of them could be making that. So the mode is not necessarily going to be a good measure of that, although that can be close. So apart from the fact that we know all celebrities make mess, that's nothing else can be determined. So that's going to be choice D. Okay. And the last one is based on the nature of the amounts. What can be inferred about their precision? So, basically when they do these numbers, it's not that they're going to have exactly 275 million or exactly 195 million or exactly 190 million. They're rounding these kind of like approximates. They may buy something expensive and then their value goes down. So, these are estimates here. The values all end in like 0 and 5. So they appear to be like about a rounded estimate. That's probably the answer they're looking for on this. I'm going to check it out. And that looks good. So they ask these kind of questions to see if you understand the data. And if you don't get these right the first time you do questions like this, you can always, you may get other guesses. And you can always do these questions multiple times in order to kind of get the sense of where they're going with this. Okay. Because it's just kind of building this sense about statistics, as part of the learning process. So I don't want to go to the next question. I'm going to jump to number 7. Okay, so in this one, it says find the mean, median, mode, and mid-range for the data set, and then we're going to answer some other questions. So we're going to do this again. So I'm going to turn this off. And let me go ahead and open this in StackCrunch again like I did before. Do a new share. Okay, and here's the new set of data that's open in StackCrunch now. So I'm going to go to stat, summary stats, columns. I'm going to pick var1. That's the column I'm looking at. It does want, it says it does want the mode. So I'm going to make sure to hold the control key down. The control key is in the bottom left corner. And then go ahead and click on that. And since it does have mean, it does have a median here. And it doesn't have mid-range, but again, we're going to calculate that. We're just going to hit compute. You see here, we have the mean, we have the median, we have the range, we've got the minimum, the maximum. So we have to do figure out all this. It says in the question, so let's go back with this information here. You can pause if you want to write this down, but I'm going to go and fill in the information that's in the questions here. Okay, so it says the mean of this. It says rounded to 2 decimal places, which is good. That's going to be 381 0.72. And it says the median, we have a median of 225. And it says the mode of the data is or are. So sometimes there may be more than one mode for data. According to the program, 500, which is 1, 2, 3, 4 times. And StatCrunch provides, this as data. So as the mode. So I'm gonna put that here. Ooh, okay. So let's take a look at this. So maybe there's a second mode, and it maybe appears that StatCrunch doesn't report all of the modes if there's more than one. So let's take a look here. So, that's just up with 5,000. Okay, that too. Oh, that looks that. Okay, so you do get one more shot in case you make a mistake. What's the mid-range again? It's the min plus the max divided by 2. The min is 39. The max is 2,500. So if you take 39 plus 2,500, you do that, and then divide by 2, you get 1,269.5. Like the answer came up for another question we just did. Maybe from the previous video. Like that answer. And then finally, it says, are there any outliers and choose the best answer? So what it wants to know is, are there answers that are significantly higher than others? Now, if you wanted to be sure these are outliers, you could do a box plot for these. But I would say that the numbers that seemed really out there would probably be, 2,000, 2,500. And just and because you will usually have more than one shot, I would go ahead and choose B first, and let's see if it likes that for an answer. Okay. And it does. Okay. So in the next question now, we're going to go to question 9. Okay. And it says, okay, so this case, we're given 2 sets of data. So I'm going to kind of show you how to handle working in StatCrunch when we're giving a problem like this. It's asking for the mean waiting time for this. So let's go and take a look. I want to know the mean waiting time for customers in a single line. So I want the mean waiting time for this. Let's go to StatCrunch. And it looks like we're going to be toggling back and forth a bit here. So I'm going to pull up the summary data for this one here. Okay. So I'm looking at the single line. I go stats, summary stats, columns. And I want to make sure to choose the single line. And I'll just run a quick test here. So the mean time is going to be let's see, here it doesn't specify the number of the amount like how many decimals it wants. So since I have the mean of 7.08, I'm gonna just put that in and see what it says. And if it doesn't like the answer, it'll tell you. Okay, it likes it. So and the median wait time for a customer on a single line, well, we have that in the answer too. The median is going to be 7. Okay. And now it's probably going to ask for the median for individual lines. So let's come back to StatCrunch and find that. And they go stat, summary stats, columns, go to individual lines, just hit compute. We have a mean for this one of, hold on, did I do that right? I feel like this is the same data. No, it looks like it is. So that's going to be 7.08. I was really surprised by that. Okay. And then the median is also 7. Okay. Was that it? I believe there's few things part of this here. Yeah, it does. Determine whether there is a difference between the two sets of data that is not apparent from a comparison of these measures of center. Okay, and if so, what is it? So, yeah, they both have the same mean and median. So you probably want to look for something like a mid-range, for example. Like if you're looking at, oops, sorry, let me share this back. So we're back here. I put the answers in. And the question is determine whether there is a difference between the two data sets that is not apparent from a comparison of the measures of center. So if I look at this, the lowest value is 6.4, the highest one 7.6. So there's not a big difference between the min and the max. If I look at this, the lowest times 4.1 and the highest one's 9.9. So big difference. Like there seems to be more variation of this. Well, let's see what the kind of answers look for. There is no difference. That's not true. The times for customers and individual lines are much more varied. So yeah, varied being variation. Times for customers and individual lines have more variation than the customers in the single line. So I think that's going to be choice A. Notice they only give you one shot at doing that. Okay. So that's question 9. And then we're going to go to the next question, go to the next 3 questions here. Okay. We take a look at this, we see we have a frequency distribution. And it wants to know the mean of the frequency distribution. So all right. And we want to calculate that then. I'm going to open this up in StatCrunch. And then let me go ahead and share that. And then how we're going to calculate that is we're going to go to Stat, Summary Stats, Group Bin Data. Select the variable, that's going to be the load temperature. The counts is going to be in the frequency. That's usually how it's going to be measured. And I think we can just hit compute from here, since it's just asking for the mean. And it appears that the mean for this is going to be 51.8. So I'm going to go back to here. And lo and behold, it likes the answer. Let's see if it asks any follow-up questions. Which of the following best describes the relationship between the computed mean and the actual mean? That's and what happens is because we're doing this in a frequency distribution, we can't be sure exactly what these values are. And what's normally done is we would there's a procedure where we find the medians. And when we find the class medians for these, this is for like 40 plus 44 would be 84 divided 2, so it'd be 42. This would be 47. We multiply each of the medians by the frequency, add these up, and then get the average of this. Okay. And the best way we can characterize this is that the computed mean is close to the actual mean because the difference between the mean is less than 5% of the actual mean. It's going to be choice D. Oops, hold on. Between the mean. Hold on. I'm gonna hang on 1 second. I'll just contemplate this. Yeah, so I figured out what was going on here. Let me resume the sharing here. Just a simple detail I overlooked when I was reading the question here. Okay, so we found a mean of 51.8 degrees. So the actual mean of the database, because they would know the individual values, is 56.5. So 51.8 is not within 5% of 56.5. And to calculate that, you would take 56.5 minus 51.8. And then you would divide that. Hold on one second. So I'm going to explain how this one's done. I'm going to share the question and then show on paper how this is done. Okay, so it gives the actual mean as being 56.5 degrees, and then it says the mean of frequency distribution is 51.8. If you want to say that the computed mean, like the weighted mean, is close, it's got to be within 5%. So how do we calculate 5%? So what we're going to do is, let me kind of show this with new share. To calculate this, we're going to take the difference of the two means. That's going to be 56.5. That's the actual one, minus the 51.8 that we calculated as the weighted mean, and we're going to divide this by 56.5. Okay. We get a total on top first. So it'll be 56.5 minus 51.8. That's going to be equal to 4.7. And now I'm going to divide this by 56.5. Well, that works out to be 0.083. That's greater than 0.05. So for it to say it's close, it's got to be within 0.05. Because that's not the case, we're going to choose a different answer. Let's go back and share that again. Okay. So we can say the computed mean is not close to the actual mean because the difference between the means is more than 5% of the actual mean. That's going to be choice A. There we go. Okay. So I just wanted to share that with everybody. That's not the kind of question I'm usually going to ask on a test, but I may be asking a question related to figuring out a weighted mean. Let's take a look at the next question now. Okay. One common system for computing a grade point average assigns 4 points for an A, 3 points for a B, 2 points for a C, 1 point to a D, and 0 points for an F. Okay, this is why I believe we're going to actually create the information here. So what is the GPA of a student who gets an A in a 3-credit course, a B in each of two credit courses, a C in a 3-credit course, and a D in a 2-credit course? So we're going to take a look at that question. You may want to pause and kind of toggle back and forth. I'm actually going to put what this chart's going to look like on paper, and then we're actually going to bring this this calculation into StatCrunch here. So because this question is a little different. So let me go ahead and share my camera here. But do please have a picture of what that question looks like. Maybe with a picture, use your phone, or like freeze it and take a screenshot. I'm gonna kind of write down and verbalize how we go through this. Okay. So got this in question here. This is for question number 11. This could be a kind of question I could certainly ask on a test where you have to come up with your own frequency distribution. So it says here it gives, so we're talking about, so an A, that's like 4 points. A B, that's like 3 points. A C is 2 points. A D is 1 point, and F is 0 points. So how do we set up this distribution? So looking at the grade, and then we're looking at the credits. So for this question here, it says we have, what is the GPA of a student who gets an A in a 3-credit course? They get a B in two 2-credit courses. So they get a B in two 2-credit courses like this. Okay, they get 2 B's basically. A C in the 3-credit course, and then a D in a 2-credit course. So here's the D in the 2-credit course. So now remember, what's an A equivalent to? It's equivalent to 4 points. A B, those are each equivalent to 3 points. A C, that's equivalent to 2 points, and a D is equivalent to 1. So here's going to be, This is going to be one column. This is going to be the other. We're going to go ahead and type this into StatCrunch now. And I'll use the StatCrunch page we generated from another question here. Okay. All right, so this is going to be 4, 3, 3, 2, 1. And the number of credits is going to be 3, 2, 2, 3, 2. All right, so what I'm going to do now is I'm going to go ahead. I'm going to go to stat, summary stats, group bin data. I'm going to go to the grade as being bins, and then the count is going to be the credits. And I just want the mean of this. So we're going to hit compute, and it's going to give the mean of 2.67. So that's going to be, so it says the nearest tenth, so it's going to be 2.67. Your 2.7. Let's try that. Okay, like that. Okay, and then the question 12. That was, so notice here, the big work was creating the distribution. And the last question we're going to do in this today, a student's, oops, let me move that over there. I think it's, oh. Guys, let me go back to the previous question again. I'm sorry, I forgot to share this. Yeah, guys, when these videos get a little long, so I typed in 2.7 to this, and that turned out to be correct. I'm going to question 12 now. And then guys, yeah, so this is my first time doing this. So you know, these video obviously these take some time to go through, and I apologize for the mistakes in this here. So a student course grade is based on one midterm that counts as 20% of his final grade, one class project that counts as 5% of his final grade, a set of homework assignments that counts as 30% of his final grade, and a final exam that counts as 45% of his final grade. His midterm score of 71, his project score is 86, his homework score is 65, and his final exam score is 66. What is his overall final score? What letter grade did he get? Okay, so again, if you want to save a screenshot of that, we'll create the distribution for that. So we're going to treat the grades as those percentages for question 12. Let's go back to my document camera and let's share that. So here are going to be the categories. And then these are going to be the grades. Okay, so we know that like the midterm, that's going to be 0.2. We know that a project, that's going to be, it says 5%, that's going to be 0.05. A set of homework assignments is going to be, so each W, that's going to be 0.3. And then a final that counts as 45. And then we're going to put the grades for each of those over here. It says here his midterm score was a 71. His project score was an 86. His homework score was a 76. And his final exam score was a 66. I don't know. Should this guy pass? I wonder. I don't know. I'm a little suspicious. But we're gonna go ahead and put that in the StatCrunch now. So that's what we're gonna put in StatCrunch. We're going to share StatCrunch now. So this will be 0.2, 0.05, 0.3, 0.45. Okay. And then each of these, let's say 71, 86, 76, 66. Okay, and again, for this question here, I'm going to go to stat, summary stats, group bin data. I want to make sure categories, grades. So I make sure I get those correct 2 columns right here. And I should just be able to hit compute. Okay, and if I look at his mean, I feel like I've done something wrong with this here. Oh no, I think this is something a little different. I think I actually can take those added together. Yeah, hold on. Guys, I'm gonna hold off on this.